Hi, in this video I'm going to explain another example of linear approximation, now into the idea of what differentials, how to use it. Here's the setting, here's the formula we'll be using. Let's get to this setting. An ice cube of side 3 centimeters begins to melt, and now each side reduces length to 2.99 centimeters. Using differentials, find how this change of side affects the volume of the ice cube. Find the absolute change, relative change, and the change of volume expressed as a percentage. Now here we have the ice cube. It's obviously sad because it's melting down. Here the side of the volume of this ice cube will be 3 centimeters. We can find actually the initial volume that we have here. Let's start by getting this volume of x. It's equal to x to the cube. This is a cube, so this is the formula. So v of 3 would be equal to 3 to the third, and v, the volume, let's just say, would be equal to 27 centimeters cubed. Now let's write this formula we have here in blue in the terms of the context we have here in this problem. So instead of the dy, we're looking for a differential of volume in here. Differential of volume. Now this v prime should be instead a v prime of, in this case would be v prime of 3 would be v times the differential of the side. I'm going to use going for a differential just to work this through. Well, let's see. So let's find the pieces of this formula. We have the v prime of 3. Well, let's start by v prime of 3 on the right. V of x, as we see, it's equal to x squared to the third. So v prime of x would be equal to 3 times x squared. Now v prime of 3 would be roughly 3 times 3 squared. And again, this 3, I'm going to better write the units, it will be 3 centimeters. So v prime will be 27, this will be 3 squared over 9 times 3 will be 27 centimeters squared. And notice there's a difference between the v prime and the v, the units signed for. And now, okay, let's jump to dx. Dx would be equal to the final side, final length of the side minus the initial one. That is to say, 2.99 centimeters minus the 3 minus the initial one. So in other words, just to erase this one. Well, dx will be equal to 0.01 centimeters negative. This is a negative result, and this makes sense because the ice cube is melting down. So this differential must be negative. Now let's get to the let's keep working this through. So v prime of 3, we know it's equal to 27 centimeters squared. Now this will be times the differential of x, which is, as we can see, negative 0.01 centimeters. Now let's work this through. Differential of volume will be equal to 27 centimeters squared times, will be negative, this 0.01 will be just the same as saying 1 over 100. So if we multiply them out, we will get to this. Will be differential of volume would be negative 27 over 100 centimeters cubed. It's very important. We multiply the centimeters squared to times centimeters, we get centimeters cubed. Now we got a differential of volume. This is how much it changed the volume in terms of this change of the side, which is this part of here. Now let's get to this absolute change. I'm going to write here in orange. The absolute change. There it is. The absolute change would be roughly what's the initial volume, what the volume we had at the beginning would be v of 3 plus the differential volume. Now let's get to it. It's v of 3, we know it's 27 centimeters cubed, will be 27 centimeters cubed, and this dv, it's negative 27 over 100 centimeters cubed. Minus 27 over 100 centimeters cubed. So in other words, this absolute change would be 26.73 centimeters cubed. So this change of side from 3 to 2.99 centimeters will affect the volume, and we'll change it to 26.73 centimeters cubed. Now let's get to the relative change. Here in pink would be the relative change, and this would be well, this is a relationship. So we can see this is how much this dV represents of the total volume. So let's write it down. The dV, it's negative 27 over 100 centimeters cubed over, this would be, the volume is 27 centimeters cubed. This is just like would be over 1. So let's simplify this using the sandwich rule. Centimeters cubed would cancel them out. So this 27 with this one. Now here, this negative sign, we can just, as we are talking of a relative change, we can pretty much ignore the sign. So let's get to this relative change will be at the end 1 over 100. So again, just this number may not tell that much. So in order to depict it in a more useful way, let's express this as a percentage. So this 1 over 100 is just the same as 0.01. So in order to express it as a percentage, we have to multiply it by 100. So this represents actually 1%. This is the I'm going to write it in, let's say, in red. This is the change expressed as percentage. That is to say, this dV represents 1% of the total volume. Well, that would be actually it with this video, this example. Hopefully it was useful to you.